Good day, viewers. You are welcome. So here we have an interesting cubic equations, which is a to the power of 3 plus 5a equals 42. And to solve this, here is what we are going to consider. So if we write this as a to the power of 3 plus 5a, so we transfer this here and we get minus 42 equals 0. So next on this, we have to break this 42 down as a is a to the power 3 plus 5a minus into bracket of, so we have 27 plus 15, so this gives us 42, then everything equals 0. So as we open the parentheses and we combine it with this one, so we have a to the power 3 minus 27, so we put this one in parentheses, plus also we have 5a minus 15, all in parentheses, equals 0. So what I did here is I combined this based on the corresponding power of this base. So we have to rewrite 27 as exponent form. Then we have a to the power 3 minus 3 to the power of 3. So we understand that this is still 27 in bracket plus. So let's try to factor out 5 from here. So as we get this as a minus 3 equals 0. So if this is what we get, so here we have a cube minus 3 cube. So this is difference of 2 cube. And the result of this one is given as a minus 3. So it's an identity we should know, and a is the template for it. So we are going to write it as a minus 3, and we create another bracket. Then in this bracket, we write a squared plus 3a plus 3 squared, and that is 9. So here is what we have for this expansion. So we can pause this video and expand this. We are going to get what we have here. So then plus 5 into bracket of a minus 3, everything equals 0. So as we are proceeding, we have a minus 3 here and a minus 3 here. So suppose we factor out a minus 3 from here. So we have this as a minus 3 in parentheses inside another parenthesis. So if we divide this one by a minus 3, what we have left is a to the power of 2 plus 3a plus 9. So this is what we get. Then plus, when we divide this one by a minus 3, so we are left with plus 5 equals 0. So here we have a minus 3 in bracket, open bracket. So with this one, we write this as a squared plus 3a plus 14 equals 0. So on getting this, since we need 3 solutions here, as from the first one, it is clearly that a equals 3 is one of the solutions that satisfy this problem. And also to get the other solutions, we consider here as a squared plus 3a plus 14 equals 0. So let's say we transfer 14 to other sides. So we get a to the power of 2 plus 3a equals minus 14. So I did this because I want to apply the completing the square methods. So suppose I add 3 over 2 square to both sides. So here we have a squared plus 3a plus 3 over 2 raised to the power of 2. I added it here. And also at this side, we have minus 14 plus 3 over 2 raised to the power of 2. So this is what we get when we want to apply the completed square method. So we take the average of this, then we square it and add it to both sides. So and here is how it works. So on getting to this at this side, we have to add this and this together, then pair it together and take the power of 2 to both sides. So when we take the power of 2 of this, so we have a plus 3 divided by 2 all raised to the power of 2. So here is what we get. The whole of this thing that has been compressed, and here is what we get, equals minus 14 plus, so 3 square, it gives us 9 divided by 2 square, that is 4. So as we are progressing, we divide this one by 1, so and we write this as it is, which is a plus 3 divided by 2 all raised to the power of 2 equals, so when we multiply 4 by 14, so we get something around minus 50, we get minus 56 plus 9 divided by 4. So then we have a plus 3 divided by 2 all raised to power 2 equals, so by subtracting 9 from this 56, we get minus 47 divided by 4. So we have to take the square root of both sides, so to get the value of that a. So we take the square root here as well, then we add plus or minus when we take the square root at this side. So this cancelled, as we have a plus 3 over 2 equals plus or minus. So we have to separate this as square root of minus 47 divided by square root of 4. So we need only a. We transfer 3 over 2 to the other side, as we have a equals minus 3 over 2 plus or minus. We have negative in this root. So when we have negative in the root, we can separate it as the square root of minus 1 multiplied by square root of 47 all divided by, so square root of 4, this is perfect square, and we get 2. We want to leave the answer in short form. That's why I will not press the value of it. I'll just leave it like this. Here we have a equals minus 3 over 2 plus or minus. So anytime we have square root of minus 1, it's known as I, divided by, multiplied by root 47 divided by 2. As we conclude this as a equals minus 3 plus or minus I root 47 divided by 2, and we call this one a2 and a3 because we have plus or minus as the answer here, which is the complex solution to this problem. And this is how to solve this. I hope you learned something today. So we can still check for this real solution and the complex solution if you like. Suppose we want to check for the real solution here, which is a equals to 3. So when we put 3 here, we are going to have 27 plus, and when we multiply 5 by 3, we get 15. Then 27 plus 15, that gives us 42. So which means that a equals 3 satisfies this, and the other complex solution also satisfies it, as we can test for it. So this is how to solve this. I hope you learned something today. Thanks for watching, and if you are new here to this channel and you find this video interesting, please do well to like, share and subscribe, and then turn on the notification bell so that you'll be aware of when I drop any video. See you.